I'm Savannah.
And I'm Simon, and we're here from Harvey Mudd CS5X Moves.
So far, the programs you've written and circuits you've created haven't relied on actually understanding what's inside a computer.
It's more or less than a black box into which you type commands and results come out.
A basic understanding of how a computer works, though, is often really useful.
Today, we'll be introducing the CPU and memory and showing how these parts of the computer might work together to run a program.
Almost all computers today, and actually since 1945, are based on a design proposed by John von Neumann.
A von Neumann architecture splits up a computer into two parts: the central processing unit, or CPU, which executes commands, and the memory, which stores information. First, we'll look at the CPU. The CPU is comprised of a little chip that is made of billions of transistors, which are connected to form gates like the ones you worked with recently in Logisim. These gates are then connected together and used to do computations such as addition and subtraction. The CPU has a very small amount of very fast memory, which is split into individual slots called registers. Registers are used to store values that are currently being used in programs.
The rest of the values that a computer needs to run are put into memory. RAM, or random access memory, which looks like this closer up, is about much larger than the storage available directly on the CPU, but also a lot slower. Values move between the CPU and RAM as they are needed. Let's look at how a computer program runs, in a vastly simplified way, to see how all these parts work together. Consider what happens when you edit an image in image processing software. An image is composed of many smaller pieces called pixels, and each pixel is made up of information such as its color. You start by loading the image into memory when you open it. Loading an image puts the values for each of the pixels into memory. Then, you run some variety of image processing on it. Say we want to change the brightness. For every pixel in the image, the computer loads the pixel from memory into a register, does a computation on that pixel using the CPU to determine what it should be after brightening it, and then stores it back into memory. The computer runs really quickly, but because of the number of pixels, we can actually see the process happening in real time when we run it. See how the darker and brighter areas move down the screen. In conclusion, computers are split into two parts, CPU and memory. The CPU executes instructions, memory stores values, and data moves back and forth between the CPU and memory as needed. These parts, working together, are what enable us to run computer programs.